In this video, we will implement linear search and also improvement of linear search by applying various methods. So already I have an array here with a few values, that are 5 values I am having. Let us use same values for the program. So here above the main function, I will write a function for linear search. Linear search should search for an element and return its index. So function name is linear search. It should take an array. So struct array arr. See, I'm not passing it by address because just by value is enough, because it has to only search for the value. Then the key that we want to search. That's all. Now the program is very simple. I need a variable I, and using for loop we can check for the element. I assign 0 and I is less than length. So arr dot length I can say, because this is coming called by value, not called by address, so I don't have to use arrow. Then I++. Every time I should check whether that key, given key, is equal to element in an array at index I. If it is found, then return index I. Otherwise, after the for loop, we can return index -1, saying that element is not found. So logic is very simple. We have already seen this. Now here I will call linear search function, and the result I will directly print it. So I will use printf %d/n, and I will call linear search function. Parameters are array, and the key value that I want to search is 4. Now 4 means I should get the index as 2. Let us run. Yes, index is 2. The key is found at index 2. Next I will search for 6. Yes, key is found at index 4. Let us give the value 15. It is not there. Index is -1. Yes, element is not found. So that's it. This is a function for linear search. We have also seen how to improve linear search by using transposition or move to front. So let us adopt those techniques. So in that, just we will swap an element with the previous element or with the first element. So for that, I will write one function called swap, which will swap two elements of type integers. So first is pointer x and second is pointer y. I will write this function, so wherever I need to swap the elements, I'll use this one. So temporary variable, then temporary variable assign the value from x, and the value of x is modified by value of y, and value of y will change to temp. That's all. These 3 lines for swapping 2 elements, I'll be using it whenever required. This is called by address. Now let us improve linear search. For improving linear search is going to modify this actual array. So for modifying this actual array, this should take address. So it should be a pointer, and here while calling, it should be an address. Then when I'm accessing the members, I should use arrow instead of dot. Now these changes I have made so that it can modify the actual array. Now before returning the element, we should swap the element. So first of all, let us see transposition. So transposition will swap the element with the previous element. So let us call swap function here by passing address of a of I with address of a of I -1. So it will interchange the element found at index I with element at I -1. So here I will debug the function, then we can clearly see how it will perform transposition. And I will search for a key element, that is 5, searching for 5. So 5 should be interchanged with 4. Let us run. I'll put a breakpoint here on printf and run. It has stopped at printf function. Let us continue. Now it has entered into linear search. Let me expand this array. It is searching for the key. It's going on the next index. The next index I is 2 now. At the bottom you can see I is 3, then the element is found. So it is swapping the elements back to this function. Now you can see that 4 and 5 has interchanged their places. So 5 came before 4. So this swapping is done and return the element. So that's all. Back to the main function. I'll remove the breakpoint and continue normal execution. So index return is 3 and the elements are changed, modified. You can see that the elements are modified. 2, 3, 5, 4, 6 now. Now next we will see move to head. So I have to just make a small change in this linear search function. I have to say swap a of I with a of 0. Just say 0, the element will be brought at index 0. Let us run and see. 5 should be brought at index 0 and 2 is sent in place of 5. Yes, you can see this change in the list of elements. So that's all about linear search. Now let us look at binary search. For performing binary search, the prerequisite or the condition is that the list of keys or the elements must be sorted. So I have taken sorted list of elements, total 15 elements I have taken. Array size is also 15 and the number of elements are also 15 and they are sorted. So this is the first and foremost condition. So why it is called as binary search? Because it will always check for a key element in the middle of a sorted list and it will split the list into 2. So that's how it is binary search. So let us see the working. For example, I have taken a key element 18 which is present here. We will search for this element. If I am performing linear search, in how many comparisons I can find 18? 1, 2, 3, 4, 5. So in 5 comparisons I'll be reaching there. Now let us see how binary search works. So for performing binary search we need 3 index variables. So those are lower, higher and mid. And this mid is low plus high divided by 2 and we will take the floor value. Now using these 3 we'll perform binary search. So what is low? Low should be initially pointing on index 0, that's the beginning of a list, and high should be pointing on the end of a list. So as per our example, low is 0, high is 14. This is initial. Now let us perform repeating procedure. Find out mid. 0 plus 14 by 2, 0 plus 14 by 2 is 7. Mid is 7. Mid is 7. So if low and high are given, calculate mid. Now check if this 18 key element, is it present here? No, this is not the key element we are searching for. Then our key element, is it smaller or greater? It's smaller. So it is on the left hand side. How you can say that? Because the list is sorted. So if the key element that we are searching is greater than this one, then definitely it is on the right hand side. But our key element is 18, so it is on the left hand side. If it is on left hand side, then reduce the list into half. Our list was from low to high till there. Now it should be from low to this point. Already this element we have checked, right? So up to this point. So move high to mid minus 1. So high should be moved here. So this should be high. High should be changed to 7 minus 1, that is 6, and low remains 0 only. So now we have split the list into 2 halves and we are checking for an element in 1 half because the other half element cannot be found. Now continue. Find out mid. Mid is 0 plus 6 by 2, that is 3. So new mid value is 3. Is it the key element that you are searching? Our element is 18. No, this is 15. So key element is greater. So it is on the right hand side of the list. So this is the present list now and this is mid. So the element is on the right hand side, means in this portion. So change this low to mid plus 1. Already we have checked this element, so don't include this one. So low should be brought on 4. So low should be changed to 3 plus 1, that is 4, and high remains 6 only. Now find out new mid. Mid value is 4 plus 6 by 2. This is 5. This is mid. Check, is it the key element? 21. This is 18. No, 18 is less than 21. Then check on which side of the list. Check on the left hand side of the list. You can observe that the list size is getting reduced and every time it is getting divided by 2. So for checking on the left hand side of a list, modify this high. High should be what? Mid minus 1. Don't include this element. So it means low was already 4. High will also point on the same location. So mid minus 1. So 5 minus 1. So 4. High is 4. So low was already 4. Now find out new mid. 4 plus 4 by 2 is a 4. So mid is also 4. Now check. Is it the element that you are searching for? Yes. Element is found at index 4. Element is found. Search is successful. So this is how binary search works. Total how many comparisons it has found the element? 1, 2, 3, 4. In only 4 comparisons we got the element. Let us take one more key and search for it. I am taking key 34. So key is 34. The values that we need are low, high, and mid. So already you know the formula for mid. Now let us start. Initially low is here and high is here. So low is 0, high is 14. Find mid. Mid value we always get same thing. 0 plus 14 is always 7. So mid will be here. So for this list mid is always same. Anyway, let us check what is the number there. Is it a key? 34? No. Key is greater than this one. So key is on the right hand side. So change low to mid plus 1, that is 8. Now this is the list in which we have to search. So low will change to 8 and high will remain 14. Now again calculate mid. Mid is 11. So mid will move to 11. So we are on the right hand side. So the list is divided into half and we are checking on the other half of it because the number cannot be on the first half. Now check, is it the number that we are searching for? No, 34 is smaller than that one. So it should be checked on this side. So modify high to 10. So high becomes 11 minus 1, that is 10, and low remains 8. Now find out mid. Mid is 9. This is mid. Is it the number that we are looking for? 34? No, that is 33. So the number is definitely on the right hand side. So modify low to mid plus 1, that is both will come on the same place. 9 plus 1, 10, and this remains 10 only. Now find out mid. Mid is again 10 only. So mid points on same thing. Yes, this is the element. So we got that element in 4 comparisons. 1, 2, 3, 4. 4 comparisons, element is found at index 10. So this is how we have seen 2 examples in which search is successful. Now let us take one example for unsuccessful search. I'll take one element which is not present here. So I'll take value that is 25. 25, it should be after 24 but it's not there. So let us take a key 25 and check it. Key is 25. Low, high and mid. These are the 3 values we need. Low starts from here, high starts from here. Now first mid value is 7, so 0, 14 and 7, mid is here. Now is it a key? Key is 25, so this is not 25, 25 is smaller, so check on the left hand side. So move high to 6, 7 minus 1, that is 6, and this is 0. Now mid is 3. Go to mid of this one, so this is the middle of this list. From low to high, this is the middle one. Is it the element that we are looking for? 25. 25 is greater. So check on the right hand side. So this will be new low, that is mid plus 1. Low becomes 4 and high remains 6. Now find out mid, that is 5. So this is mid. Now, is it the number that we are searching for? 21? No. 25 is greater than that. So 25 is on the right hand side. So modify this low, and low also becomes 6, that is mid plus 1. So 5 plus 1, this is also 6 and this is also 6. Find mid, this is 6. So right now low and high and mid, all of them are on 6. Now is it the element that we are checking for 25? No, 25 is greater. So modify low. If it is greater, we'll modify low. So low will become what? Mid plus 1. So what is mid right now? It is 6. So low will become 7. So mid plus 1, low will become 7 and high is 6 only. Now we will stop. We will not find mid now. We will stop. Reason, low has became greater than high. Low has became greater than high. Low should be on the left hand side and high should be on the right hand side. But low became greater than high. So it means the element is not there in the list. So search is unsuccessful. So this search is unsuccessful. So these two keys were found and they were there in the list. 25 is not there in the list. Now let us see how many comparisons it has taken. 1, 2, 3, 4. 4 comparisons, and here we don't do anything. Stop. So in 4 comparison we got the result that element is not there. So this is how binary search works. Now let us write the algorithm for this one. So I will write the algorithm for binary search. The syntax may be more like C++ syntax, but I am writing pseudocode. Algorithm binary search. So what are the parameters it needs? It needs 3 parameters: low, this one, and high, and key value that we are searching. So which key we are searching? So this is key. So these were the parameters. Then what we were doing every time? We were finding out mid. Mid is low plus high divided by 2, and we have to take the floor value. Then we were checking whether the key is present at A of mid. If a key is equals to A of mid. If you remember, we were getting the middle element, this one. So we were checking whether this is the key element that we are searching for. If so, suppose we are searching for 27, then it is found. It is found. So return the index mid. That is, this is the index, it is found. So return it. No, if the key element is smaller, then check on the left hand side. So else if key is less than A of mid. So if it is on left hand side, we were modifying high to mid minus 1. So high should be changed to mid minus 1. If it is not equal, if it is not less, then it must be definitely greater. So we have to check on that side and modify low to mid plus 1. So modify low to mid plus 1. So else we will modify low to mid plus 1. This is what we were doing. So we have to go on doing this until the element is found. Or if the element is not there, we should stop when low becomes greater than high. So this means we have to do it repeatedly. How long we should do this? While low is less than or equal to high. We should continue this. So we should stop when low becomes greater than high. If low became greater than high, then we stop, means the element is not found. So we can return minus 1, saying that the key element is not found. So this is a iterative procedure that is using loop for binary search. I have just shown the algorithm or pseudocode, though it is more like C++ code, but the perfect executable code I will write down when I show you the program. This binary search algorithm is written using loop here, that is iterative version. We can also write a recursive version. So let us write a recursive version for performing binary search. Algorithm R binary search. What are the parameters it needs? Same parameters, low, high and key. So low, high and key. These are the 3 parameters. Now as it is recursive, so it will be calling itself. So what is the first thing we should check? whether there are some elements or not. So we should check that low should be less than or equal to high. If low is greater than high, we cannot perform anything. So we will check first thing, that is if low is less than or equal to high, then only we will consider. So if low is less than or equal to high, at least there is one element. If low is greater than high, means there are 0 elements. So first condition we check. Then after that we will find out mid, and mid is low plus high divided by 2, and that is floor value. And we check if key is equals to A of mid. If so, then the element is found, so return mid. So it is similar. Almost it is similar. Else, if the element is on the left hand side, check if key is less than A of mid. If key is less than A of mid, then we have to search on the left hand side. So this procedure can call itself recursively for searching on the left hand side. So say return R binary search, R bin search. So this is recursive call. So what it has to pass? Low as it is, but in place of high it should be mid minus 1 and key as it is. So this is a recursive call with modified list or reduced list. So it is just passing left hand side list. So if mid is here, from low to mid minus 1 it will be passing. So if the key is less, it is on the left hand side. Otherwise key is greater and it is on right hand side. So else return R bin search mid plus 1 and high as it is, and the key also. That's all. If low is less than equal to high, do all these things. If low is not less than equal to high, then return minus 1. Means key is not found. So this is a recursive procedure for performing binary search upon an array, and assume that array is global. So I am not taking any parameters here. Otherwise array should also be taken as parameter. If it is not there, means we should assume that it is global in algorithms. So these are the iterative procedure as well as recursive procedure. Now if you observe that recursive algorithm, it is tail recursion. See, at returning time there is nothing. Either it performs this recursive call or this recursive call, and after the recursive call, so there is nothing it has to perform. So it has to check for the element that it is checking beforehand only. So in this portion it is checking for the elements, right? It is checking for the elements. Then after that it is calling itself. So at returning time it's not doing anything. So instead of writing a tail recursion, you can also write a loop iterative version. So already we have discussed that tail recursion and loops are similar. So if you have to write tail recursion, better go for loop. So this procedure is better because this uses a stack. Internally it uses a stack. Now next we will do the analysis of binary search. In this video we will see binary search functions. I will write iterative version as well as recursive version. So first of all, let us write a iterative version. Binary search, it should take a parameter that is array, and it's going to just access the elements. It's not going to modify them. So call by value is sufficient, and the key that we want to search. Now for performing binary search, we need following variables: low, mid, and high. Low should be initialized with 0 and high should be initialized with length minus 1 because the last element is present at length. So length minus 1. So these are initialized. I will write return 0 to avoid this error. Then the procedure is using a loop while low is less than or equal to high. Find out mid. Mid is low plus high divided by 2. Then check if the key is same as A of mid. If it is same, then we got the element and return its index. The index is mid. Else if key is less than A of mid, then we will modify high value to mid minus 1. Else definitely it is on the right hand side, so we'll change low value to mid plus 1. That's all. In this loop, it will check for the element. If it is found, it will return its index. Otherwise, if it is outside the loop, means we should return minus 1, saying that the key element is not found. So this is the same code what we have discussed on whiteboard. Few changes are there like parameter and these low, mid and high, which I have declared them. Now let us call this function inside main function. So I will directly show its result. So I will use printf %d /n and I will call binary search function by passing array, and the key that I want to search is 5. Let us run this. I got the index 3. Yes, see, this is 0 and 1, 2 and this is 3. I will change the key value to be search. I will give the value as 2. Let us run this. This index is 0. Yes, correct. I'll give the key element as 10. 10 is not there in the array, so I should get index minus 1. Yes, index is minus 1. That is, key element is not found. I'll give the element as 15. Let us run. The element is not there, so it should return index minus 1. Yes, index is minus 1. So that's all with this binary search. Let us write a recursive binary search function which takes parameters low, high and the key value. But here I will also pass an array. So let me write down the function name as bin search, bin search. It takes 3 parameters. First is an array, low, high and the key value. These are the parameters we'll be passing. And here I will write down return minus 1 to avoid the error. Now inside the function we also need a mid. Then I will write on the procedure that we have seen. If low is less than or equal to high, then only we will check for the key. And the method for checking a key is first find out mid, that is mid is low plus high divided by 2. And check if key is equal to A of mid, the array middle location. If so, then return mid. Else, if key is less than A of mid, then we will check on the left hand side. So I will write return bin search. I will pass array A and low as it is. Instead of high, we will pass mid minus 1 and the key as it is. Else, we will return. Now we have to check on the right hand side. So I will say bin search array as it is. Low, I will change it to mid plus 1 because we have to check on the right hand side. High as it is, and this is key. This is the recursive function for binary search. Now let us call this binary search from the main function. I will change this bin search we have to pass array, so arr.a array. Then low is initially 0, definitely. Then high is arr's length. And the key that I want to search is 5. So I have sent the sufficient parameters for this bin search. Let us run the program. Yes, we got the index 3. I'll change the key to 2 and run it. Yes, index is 0. It's working. I'll change the key to 9. 9 is not there, so I should get the index as -1. Yes, it is -1. So it's working. That's all with the binary search functions. I have shown you both iterative version as well as recursive versions. And you can debug these programs and check how the low and high values are changing and how it is finding calculating mid every time. So that's all in this video. Now let us do the analysis of binary search. So for the same list, if you observe, when we have searched for various keys, every time mid value was 7. Obviously 0 to 14, middle is 7 only. Initially low was here and high was here, and we were getting mid. This is mid. So always we were getting mid at 7. So if suppose we are searching for a key 27, then in first comparison only our search should terminate that key is found. So it means that key value at index 7, the key value 27 can be found in just one single comparison. And next we were searching for the element on the left hand side. So high was here and mid was this one. So for the left hand side, middle element was 15, the index was always 3. So on the left hand side, middle one is index is 3 and the element is 15. Then on that side, if we check, if we are checking for an element on right hand side, then the low will be this one and high will be this one, and this we will get it as middle, that is index 11 and the element is 37. Index 11 and element is 37. So it means if you are searching for 37, then it will be found just in two comparison. First time we will check for index 7, that is 27, element is greater 37, go on the right side, take the mid, we get this mid, element will be found in two comparison. So from this list, this will be found in one comparison and this will be found in two comparison and this also in two comparison. What about remaining? So I will quickly write down about the remaining one. If I take the left hand side list, that is from 0 to 6, the middle element was 3. Then on the left hand side, if I take this list, then the middle will be 8, that is index 1. So this will be index 1 and element 8. Then on the right hand side, this list, this is the middle one, index 5. So here right hand side is index 5 and the element is 21. For this 8, left hand side is 0 and element 4, right hand side is index 2, element is 1. So if I remove this, you can see that this is on the left hand side. So this is on the left hand side, this is on the right hand side. So for this middle one is index 1, left side is 0, right side is 2. So this will be 0 and this will be 2. And the element here is 4 and element here is 10. Now this side, left hand side is 4 and element is 18, right hand side is 6, element is 24. So this is 18 and this is 24. Now similarly, I'll prepare for the right hand side also. So for right hand side list, leaving this as middle, this is the right hand side and this is the mid one. So 11. Then for these three elements, this is the mid one. So left hand side is index 9 and its left is index 8 and its right is index 10. So the elements are 33, 29 and 34. And on its right hand side, these are the three elements, middle one is 13. So this is 13 and on its left hand side is 12, right hand side is 14. And the elements are 39 and this is 41 and this is 43. So this is a tracing tree we got based on the working of binary search. So we will discuss from this tree. Now if you observe, 21.7 can be found just in one comparison. Then 15 and 37 can be found in two comparisons. Means if the element is 15, we go on the left hand side. If the element is 37, we go on the right hand side. These elements which are at level 3, these will be found in 3 comparisons. And these elements will be found in 4 comparisons. So maximum how many comparisons are required? 4 comparisons are required for searching, not more than 4. Whether the element is in the beginning of a list or at the end part of a list, wherever the element is, maximum comparison required for searching are 4. So from the tree you can clearly see that at most 4 comparison to reach any element. So the number of comparison depends on height of a tree. This is a tracing tree, so the height of this tracing tree is log n. So the time taken will be dependent on the number of comparisons, and the number of comparisons are at most log n. So the time taken for searching in binary search is log n. So minimum time is, if you are searching for an element which is present in the middle, so the minimum time is order of 1, so you can say this is the best case. And what is the maximum time taken if the element is present here? According to this tree, if they are present in a leaf, or those elements which are reachable, they are found at 4th comparison. So the maximum time is order of log n. This is the best case time. This is the worst case time. So best case time of binary search is order of 1, and the worst case time of binary search is log n. So this was about successful search. What about unsuccessful search? Let us see. If I am searching for any element that is smaller than 4, then what happens? I'll check here. 4 is smaller than this, 4 is smaller than this, 4 is smaller than this, 4 is smaller than this also. So it will end up on the left hand side. If I am searching for any element which is present in between 4 and 8, then what happens? Let us see. 4 and 8. Let us take one element 7 and see what happens. 7 is smaller than this, 7 is smaller than this, 7 is smaller than this, 7 is greater than that. So it will end up here. So it means this node, the one which is a squared node that I am showing, or representing unsuccessful searches. So this node is representing all those elements which are smaller than 4, which is not there in the list. And this represent all the elements that are in between 4 and 8. So those are 5, 6 and 7. These 3 elements it is representing. Similarly, we can represent the nodes here for all those elements which are not there in the list. So if you are searching for any element, then we say that the search will terminate at these nodes. So for unsuccessful search, this shows that it reaches at the end of a tree always. So the time taken in unsuccessful search is always order of log n. So successful search, minimum is 1, maximum is log n. For unsuccessful search, it's always order of log n. Next, we have also seen a recursive procedure. So that recursive procedure also behaves in the same way. First, it will go in the middle. If the element is small, then it will search on the left hand side, that is in the left subtree. If it is greater, it will search in the right subtree. Then again, it will call itself recursively on the left sublist or right sublist. So the maximum number of comparisons it may be making, or the maximum calls it will be making, will be at most 4. And if the element is not found, then it will be a 5th call. It will stop at 5th call if the element is not found. So the number of calls a recursive algorithm will make depends on the height of a tree. So that is log n. So whether you write a iterative procedure or recursive procedure, the time is log n. So how binary search is log n, I have shown you. Now I'll show you using some other method how binary search is log n. See, we have total 15 elements here, 0 to 14. 15. 15 is not in powers of 2, so I will just make it round as 16. Okay, to explain you how it is log n, I'll take it as powers of 2, that is 16. Assume that the number of elements are 16. Number of elements are 16. So how binary search is working? 16 it has divided by 2. So 8 elements this side, 8 elements that side. Assume this one. So 8 elements we are getting. Actually here we will be getting 7 elements, but as we have taken it as 16, so 8 on this side, 8 on this side. If you are searching on the left side or searching on the right hand side, again divided by 2. Then again divided by 2. So how long this can get divided? Until you are left with just one number. If there is only one number, beyond that you cannot proceed because there are no numbers. So last one, it should stop at 1. So 16 divided by 2, divided by 2 and divided by 2. So how many times I should divide 16 by 2 such that it reaches 1? So I should divide 16 by 2 power 4 so that it reaches 1. So that's all. So it means this list will be divided 4 times to reach at last one single elements. See, these were total 16 elements, assume this, half, then this half, then this half, then we got just one element. Either our search stops here or at last it will stop here. So this is 4. So the answer we got it as 4. So how do you calculate that? 16, how many times it should be divided by 2 to get the answer 1? It's nothing but 16 is equals to 2 power 4. So 4, this is nothing but 2 power 4 is equals to 16 and 4 is log 16 base 2. So actually inverse of power is log. Inverse of power is log. So 2 power 4 power is 16. Then how much is 4? Is log 16 base 2. So log n. So this means the time taken is log n base 2. So when I have made it in powers of 2, so I can explain you here. Otherwise 15 means 15 by 2, 7. So we will not get exactly in powers of 2. So I have taken an example as 16. So from 16 we can observe that log n base 2. So here we can say that whatever the number of elements you have, n plus 1, then log base 2. Exact answer, we got this one. 15 elements were there, then in that you add 116, so log n base 2. So exact formula is log n base 2 and so exact formula is log n plus 1 base 2. So but roughly we take it as log n. So because the polynomial degree is log n, so we take it as log n. Then one more thing. If there are more than 15 elements, then definitely the number of comparison will increase by 1 because that is the maximum number for which we require 4 comparisons. Otherwise, if the number is greater, then it will be 5 comparisons. So that I can show you here, that is if you have 16 elements, then 16 plus 1 log base 2 is nothing but log 17 base 2. So this will be 4 point something. So suppose 4.2, then this should be taken as 5. So this value should be taken as ceil. Log base 2 n plus 1 should be taken as ceil. So I have shown you from the tracing tree and also I have given you the idea, just the idea. This is not the method or an approach. Just I have given you the idea how it is log n. Because every time getting divided by 2. So when something is successive division is nothing but log. Successive multiplication is power. That's all about binary search and its analysis. Now let us do average case analysis of binary search. So average case means total time taken in all possible cases divided by number of cases. So what are the cases? I may be searching for an element which is present here in the middle of a list or root of a tracing tree. So how many comparison it requires? Just one comparison required. Then next case is this one. I may be searching for 15 which is present here, which is in the middle of the left sublist, or 37 which is middle of the right sublist. So I may be searching this one or this one. So 2 cases. These 2 elements. How many comparisons required for these 2 elements? 1 comparison required for these elements. 1 comparison required. So I have included both 1 into 2. Then these 4 elements. How many comparisons required for each? 1, 2. For here also 1, 2. For this also 1, 2. So there are 4 elements which require 2 comparisons. Then 1, 2, 3, 4, 5, 6, 7, 8 elements which require 3 comparisons. So there are 8 elements which require 3 comparisons. So this is growing in the form. So for 15 elements we have taken an example, but we have to give it in terms of n elements, whatever the elements may be. So if we observe this, this can be written as 1 plus 1 into 2 power 1 plus 2 into 2 power 2 plus 3 into 2 power 3. So it is written in terms of powers of 2. Now this can be written as sum of I into 2 power I. So how I is taking the value? So here I is power 1, power 2, power 3. Just ignore this 1. So we can have a summation formula from these terms. So I starts from 1 to 3. So I start from 1. What is that 3? See, this is 1, 2, 3, 4. So this is height of a tree. Height of a tree. So height of a tree is measured by taking it just 1, 2, 3. So that is log of n. Log of n. So this is approximately log of n. So this log n is the height of a tree. So as many levels or whatever the height of the tree is, depending on that many terms we have to take. So here it is 1, then 2, then 3. So this is the total time taken in all possible cases. That is sum of the times taken in all possible cases. So I have taken the total number of comparison required for searching each and every element. Then this should be divided by n, because total n elements are there. So that is the sum of all the possible cases divided by number of cases. So what is a case here? Each element is a case. Sum of the times of all the elements divided by number of elements. Then this numerator, this is approximately equal to log n. I is replaced with log n, and here also I is replaced with log n into 2 power log n, and this is divided by n. Then this can be written as log n, and this power n can be brought here. So this will be n log 2. So here we are taking the values in powers of 2. So that is log 2 base 2. So this becomes 1 and divided by n. So this is n gets cancelled. So the answer is n log n. So the average case analysis also log n. See, when we are finding average case, then we have to solve this one. Summation formula. Like I already told that finding average case analysis, finding average case results is time consuming. Sometime you cannot get the result, exact result. We have to take approximate one. If you want, you can convert this one into integration formula and you can apply the limits and get the result that approximately this will be log n into 2 power log n only. So average case time is also log n. So we have seen best case time is 1. Worst case time is log n, and average case time is also log n. Then we'll do some more analysis on this one. Let us do average case analysis for successful search as well as unsuccessful search. Successful search is if the element is found. So that is represented by these circular nodes. And unsuccessful search is element is not found. That is represented by these square nodes. For finding the average case time for successful search, we have to consider these internal nodes. The internal nodes require how many comparison? That depends on the level. 1 comparison for this, 2 comparison for this, 3 comparison for these elements. Depends on level. But here we can count edges, the path. See, this is 2 edges away from root. So to reach here, we require 3 comparison. So the path plus 1 we can say, path plus 1. So for every node we can take the path and plus 1. So for all the nodes we can take the paths of all circular nodes. So these circular nodes we can call them as internal nodes. So let us say I is the sum of the parts of all internal nodes. I represents sum of the parts of all internal nodes, which are representing successful search. Now these square nodes, let us call them as external nodes, which are representing unsuccessful search. So let us say E is the total parts of all external nodes. So sum of the parts of all external nodes. So there is some relationship between this one. If E is the sum of the parts of external nodes, then I is the sum of the parts of internal nodes, then this is always true. E is equals to I plus 2n is always true. So a small example I will take and show you. Like suppose there are 3 internal nodes. So definitely there will be 4 external nodes. Now number of nodes are 3. Now sum of the paths of internal nodes. See, the path of this one is 1. The path of this one is 1. So total path is 2. Then for the external nodes, for this the path is 1, 2. For this also 2. So there are 4 nodes whose path is 2. So this is 4 into 2, that is 8. So this E is equals to I plus 2n. So this is 2 plus this is 2 into number of nodes are 3. So this is 2, 3, 6 plus 2, that is 8. So here with an example I have proved it. Then one more fact we will take, that is number of external nodes are equal to internal nodes plus 1. So if there are 15 circular nodes, there are 16 square nodes. So number of external nodes will be 1 more than number of internal nodes. So this is another fact we will take. Now what is average successful time for n elements? So average successful search time for n elements is equals to total paths of all internal nodes divided by number of nodes. So we will get average path. And we know that for this node path is 2, but the number of comparisons are 1 extra. So for every node 1 extra comparison is there. So average path plus 1. So this gives average successful time in terms of paths of internal nodes. Then what is the average time taken for unsuccessful search? So average time taken for unsuccessful search for n elements is E by total number of nodes, average time. So total number of nodes are, we know that if n nodes are there, then external nodes will be n plus 1. So this is n plus 1. Average successful time, average unsuccessful time. Now there is one more fact that I have to highlight here, that is all these external nodes are at same height. So I can take the path as log n. So total how many nodes? N plus 1. So n plus 1 into log n. So approximately E is equal to n log n, or n plus 1 into log n plus 1 we can take, or else n log n. So how much is the time taken in unsuccessful search? This can be taken as n log n divided by n plus 1. So we can take it as approximate n plus 1 and cancel this one. So that is log n. So average unsuccessful search time is also log n. Now don't get confused that how I am dividing n by n plus 1. So that plus 1 you can ignore it. Right, approximate result we want. Directly I am cutting off n by n plus 1. See, for knowing the time complexity, we need the approximate, we need just the idea. So for that idea, we can take the approximate value. We don't have to be very accurate. So this is n plus 1. Assume that this is also n plus 1. As I said, this will be n plus 1, but we are writing n here. So n plus 1 gets cancelled. So it is log n. So average unsuccessful search time is log n. Then what about successful search time? See, from this formula we can say that E and I are related to one another. Yes. So in this formula I will replace E, because E is how much? N log n. So let us change this formula. So here I will do workout. Average successful for n is equals to 1 plus I by n. E is equals to I plus 2n. So I is equals to E minus 2n. So this can be written as 1 plus E minus 2n by n. This can be written as 1 plus E by n minus 2. Now E, what E is? So already we know the answer, that is n log n. So this can be taken as 1 plus n log n by n minus 2. So this gets cancelled. So this is approximately log n. So average successful search time is also log n. In this video we'll look at these operations. So that is get operation, set operation, finding maximum of all the elements and the minimum, that is smallest element in a list. Then we will find out how to find the total, all sum of all the elements, and also average. So let us look at these one by one. Now the first one is get operation. This is a very simple operation. Get means we want to know an element at a particular index. Suppose I want to know what is there at index 9. So the element is 33. So get the element from that index. Now only one thing we have to take care is whether the index given is valid or not. Like length of a list is, maximum index is 14. So total 15 elements are there. So we should not give any index beyond that 14. So it should not be greater than or equal to length. And even it should not be less than 0. So the first thing what we can check is if index is greater than or equal to 0 and index is less than length, then this is a valid index. This index checking we may require at many places to know whether the index is valid or not. This is how we can check it. So this is the condition for valid index. If this condition is true, then the index is valid. If it is valid, just we have to get the element at that particular index. So we can just return the element from an array at given index. That's all. So I have just written a pseudocode. It's not a complete function or something. When I write the program, that time I will show a complete function. So what is the time taken by this one? Just checking a condition and getting an element. So there are only 2 steps, so the time is constant. So that's all about get. Now let us look at set method. So the code will be similar to get, so I'll just change the name of this method. Second one, that is set. This method is to replace a value at a particular index. Suppose I want to replace a value at index 6. So whatever the value is, I want to just replace with this new value. So set, replacing a value or overwriting a value. So for setting a value at a given index, again I should check whether the index is valid or not. If it is valid, then I should change that index location with the element x. So that's all. Now get method was for reading the value, set method is for writing the value depending on a given index. So the time taken by this is also constant. Now let us move to the next method, that is finding maximum. So for that I will change the list because this is a sorted list, so I'll take some other list. Now let us look at max operation, that is finding the maximum out of these elements. So I have a list of size 10. So the size is 10 and also I have all 10 elements present there. So the length is also 10. So from this list, if you check, the largest number is, here I have 15 is the largest number. So this means unless I check the entire list, I cannot say which is the maximum element. For finding a maximum element in an unsorted list, I have to check the entire list. If the list is already sorted, then last element is a maximum element. So for unsorted list, I have to check all. So let us see how I can check it. So for that, I will take one variable called max, and in that I will store the first element, that is a of 0. So this element I will keep it there. So max is now first element, that is 8. Now go on comparing this with all the rest of the elements, and if any larger element is found, then replace this one. So let us do it. 3, is it greater than this one? No. 9, is it greater than this one? Yes. Modify this to 9. Then 15, is it greater than 9? Yes, we got still greater than this. Then 6, is it greater? No. 10, it's not greater. 7, it's not greater. 2, it's not greater. 12, it's not greater than 15. 4, it's not greater than 15. So the remaining one there is the largest element. So this is simple. And how much time it has taken for doing this? If you observe the work I have done, I have gone through all the elements once. So the time is order of n. Now the same thing I will write it as a code which will find out the maximum. So I have to traverse from first element onwards till the last element. So I can scan through all these elements or traverse all these elements by using a loop. So for I assign from 1 onwards, because already 0th element we have taken in max, then I is less than length and I plus plus. Now what I have to do every time? As I is starting from here, I should check that whether that A of I is greater than the maximum, that is this maximum. If A of I is greater than max, if any element is greater than that max, then copy that element in max. So inside max, copy that element A of I. That's all. So at the end of this loop, we will be having the largest element in the max. If you want, you can return this one, return max. So function we will see afterwards. Now let us see the analysis. See, inside the code also, I will write down here, this statement takes 1 unit of time, this statement takes 1 unit of time, and this conditional statement is inside the loop. So how many times it will execute? It depends on number of times the loop will execute. Loop will execute from 1 to last element. So just one element less. So almost n minus 1 element. So this will be executed for n minus 1 times. Then the loop itself will execute for n times. One extra. Why one extra? Because this condition will be checked for n times. So for n minus time the condition will be true, and one more time the condition fail, that is I becomes equal to length, so it will stop. So that termination condition also. So this is n minus 1, and this may execute always, may not execute always. So finally this is how much? 2n, this plus finally this is how much? 2n, and 1 gets cancelled, so plus 1. So the time function for this one is f of n is equals to 2n plus 1, which is of degree 1, so it is order of n. That's all. So from the code, if you want to do analysis, you can assume every statement takes 1 unit of time and find out how many times a statement is repeating. Then you can come up with some formula. From the formula you can write on the degree, and that is order of n. Otherwise, if you know how you are working on this one to get the answer, based on the working also you can tell the time. So basically you should tell the time complexity based on the working. That's more better. Now next operation is finding minimum. So it is just similar to maximum. So what I have to do is, this method is minimum, and first element I should call it as minimum. So this 8 should be as minimum, and I should go on checking if any number that is smaller than that is found, then replace it. 3 is smaller, replace it. 9 is not smaller than 3, 15 not smaller, 6 not smaller, 10 not smaller, 7 not smaller, 2 is smaller, 12 is not smaller, 4 is not smaller. So finally you got the answer. So instead of checking for greater than max, then check it for less than min. And if so, modify min. This is min. And the result is also min. So the code is similar. The procedure is similar. Just instead of max, we are finding min. So the time complexity is also same. Analysis is also same. We have to scan through all the elements, that is n is the time. Now let us look at finding sum of all the elements. For finding the total of all the elements, I should traverse through all the elements and go on adding them to some variable, that is total. So for example, I will have one variable, let us say total, and whose value is 0 initially. Then go to a of 0 and add to this one 8. Then go to a of 1 and add to this one. Then go to a of 2, then add to this. So every time I should add a value to that total. So traversing through all the elements. So I need a variable that is total. That should be initially 0. I should scan through all the elements. So for I assign 0, I is less than length, then I plus plus. Then inside total, I should every time add a of I. That's it. Then return total. Now next is analysis, how much time it takes. We are scanning through all the elements one by one and we are going on adding them to total. So for all elements it's n. Total elements are n, so the time is order of n. Otherwise from the code, if you see, this statement is simple statement, constant time. This is constant time, and this will repeat for how many times? It is going from 0 to length. So n times, n elements are there. So we assume length elements, we have length elements equal to length, but let us say n. We usually write the time complexity in terms of n. Then I starts from 0, I reach till length, then it will stop. So up to length minus 1 it works. And for length also it will check the condition and stop. So this is plus 1. So as actually inside the for loop, this will execute only for one time, this will execute for n time, and this will execute for n plus 1 time. So that n plus 1 we are writing here. So it means we are ignoring these two. Yes, we are concerned about this condition, so we have written that condition. Then total how much? 2n plus 3, so 2n plus 3. So the time function is f of n is equals to 2n plus 3. Degree of this is 1, so it is order of n power 1, that is n. So this is a simple task for adding. Now the same task we can also write it recursively. Let us look at a recursive definition for finding the sum of elements in an array. Suppose the function name is sum and it takes array and number of elements n. This n is length minus 1. So here the array starts from 0 onwards, so the last index is 9. If the array starts from 1, then last will be 10, so we can say number of elements. Now this is the last index. This is an array and this is the last index. So let us say this is number of elements. Then what is sum of all elements in an array? Sum of all the elements in an array can be recursively defined as sum of n minus 1 elements. So for n element, sum of n minus 1 elements plus nth element. This is how we can define it recursively. For n greater than or equal to 0. When n is less than 0, then it is 0. Means less than 0 means minus 1, minus 2, if anything you give, then that is 0. So this is the recursive definition. For this recursive definition, I will write down a function. Int sum a and n. This is pseudocode. I am not writing a C or C++ function. Then if n is less than 0, return 0. This one. Then this one. Else return sum of a comma n minus 1 plus a of n. That's all. The sum function must be called by passing sum array A and length minus 1. That is the last index of an element, 9. This should be called like this. Call should be like this. So if you want to know the time taken by this one, so this will be calling itself. How many times? It depends on the number of elements. So time is order of n. It is calling itself only one time for all the elements. It's order of n. And recursion uses a stack. So the size of the stack will be number of elements. So recursive calls will be piling up one above another depending on the number of elements. They start from last index towards the first index 0. So that's all about sum. Now let us look at average. Average is nothing but sum of all the elements divided by number of elements. So already we have seen a method for sum, for finding sum. Now let us just change it to average. So the next operation is average. So for average we have to find the total. So this total will be getting the total number of elements, then simply return total divided by number of elements. That's all. This will give the average. Once you have a sum, then the final operation is total divided by number of elements. So these were the simple operations on an array. Now in the coming videos, we'll look at more operations on an array. In this video, we will write all those small functions like get, set, finding maximum and minimum, finding sum of all the elements, and also calculating average. So let us start with the first function, that is get. It will take the index and returns the element. So the function return type should be integer type because our array is integer, then it should take a index. But along with the index, it should also take an array. So the first parameter is struct array, and it should be called by value because it's not going to modify a array. Now this is a simple function. If the index is valid, then we should return the element at that particular index. So first check whether the index given is valid or not. So if index is greater than or equal to 0 and if index is less than array's length, then it is a valid index. If yes, then simply return array of a of index, whatever the index is given. Otherwise, return, it's an invalid index, so we can return a value that is -1. So this is a simple get function. Now I will also write down set function and we will try all of them inside main function. Set function will change the value at a given index, so it needs array itself, that is by address and the index and the new value that we want to change. So it will set the value at a given index. So before setting, first of all check whether the index given is valid or not. So same thing, whether index is valid or not. Index is greater than or equal to 0 and index should be less than ARR's length, array's length, then it is valid. If it is valid, then in an array we will change the value at a given index to new value x. That's all. This is a set function. Now let us write a function for finding maximum element, max. It should take a array structure and again it is called by value is sufficient. Then here I should have one variable for finding maximum, so max assign. First a of 0 value we will assign, so first value we will take it. Then also we need a variable I for running the for loop. So for I assign 1 onwards, I is less than a's length, and if a of I value is greater than max, then we will change max to a of I. So let us enclose this inside a bracket. At the end, we will return whatever the max value that we got. So this is the function for finding maximum. Now let us write a function for finding minimum. So I will copy this function and I will simply modify this one to make a function for finding minimum. Change the name to min and variable name also I will change it as min. Then if a of I is less than min, then change min to a of I and return min. So I have modified the function for finding min. So I wrote get and set functions as well as max and min. Now let us write a function for finding the sum of all the elements. Sum, it should take a array structure so it's going to be a very simple function and I need a variable I for running for loop. For I assign 0, I is less than ARR's length and I plus plus every time, and in this s variable we will add a of I values. So that's all, whatever the values are they will be added. Then we will return s. The result is in variable s. So this is a function for sum, finding sum. Then at last we need a function for finding average, so I will take float avg which takes array arr I don't have to add all the elements, already I have a function for finding sum, so let us call that function sum by passing array and divided by arr dot length. This will give the average and this value should be of type float, So I will make it as float, typecast it as float. So average function becomes simple. Now let us try all these functions and see. So the functions which directly return the result, I will use printf. So first function I will call is get %d/n, and here I will call a function get by passing array, and the index is 2. So at index 2 value 4 is present, so it should return 4. Yes, result is 4. I will send the index 0, the value should be 2. Yes, value is 2. I'll give the index 9. Index is not there, so it should return -1. Yes, it has returned -1. So perfect, it's working perfect. So I will remove this. Next, let us try a set function. I will call set function by passing address of a array, and index is 0. At that 0th index, I want to write a value 15. So this 2 should be changed to 15. This should be changed to 15. Let us run it. Anyway, afterwards we are displaying all the elements, so you can see that the elements are changed. So the first element was 2, now it has become 15. Yes, it is changing the value. So it's not inserting an element, it is just changing an element at a given index, replacing an element. Now let us call max function. So I will directly print the result %d/n max function. I will pass array, and here inside the array I will change one element to 14, so I should get maximum element as 14. Let us run the program. Yes, maximum element is 14. I'll make this as 25. Yeah, maximum element is 25. Now I'll just change this function to min, and let us see what is the minimum value. I will get the value as 2. Minimum value is 2. Yes, result is 2. I'll change the value to 23. So now the minimum value is 3. So I should get the result 3. Yes, result is 3. Now I will change this function to sum. Total sum of all the elements is 71. So if you add them, you may get 71. Then average for this array. See, it should be a float type. So I will change this to float. See, the average is 14.2. Perfect. So that's all. We have implemented all the functions. So that's all in this video. Yeah, in this video we'll talk about these operations, that is reversing a list, that is array, left shifting of elements, left rotation of elements, and this right shift and right rotation are similar to these. So I'll be discussing these operations. Let us start with reverse. For reversing an array, we have two methods. Let us look at the first method. So in first method, we will take an auxiliary array, the extra array. So we'll take one array, let us call it as B. In this array, we will copy all those elements from the actual original array, and we will copy them in reverse. So from last element we'll copy. So the first element that we'll copy here will be 4. 4 is copied here, 12 is copied, then 2 is copied here, then 7 is copied, then 10. So in this way we will reverse copy all the elements. So the elements are reverse copied. Then now we will copy these elements back into the original array. So corresponding elements, same location elements will be copying. So this becomes 4, then this becomes 12, and this becomes 2. So we'll replace the elements in a original array. So this is first method. In first method we require an extra array. How much time it is taking for reversing the elements? So reverse copying from A to B So from A to B, when you copy the elements, the number of elements are n. Then again you have to copy the elements from B to A. So B to A, again there are n elements. So total 2n. So it is order of n. So the time taken is order of n. Now let us write down the code for reversing the elements using auxiliary array B. We have to copy the elements from A, that is from last index, in B starting from first index. So we will take two integer index pointers. I starts from there and j starts from here. I will be decreasing and j will be increasing. So this can be done using a loop. I starts from last index's length minus 1. This is length minus 1. And also we need j, that is j assigned 0. So we'll be doing two initialization, then semicolon. So we can have two initializations in for loop separated by comma. Then comes semicolon. How long we should do this? Until I reaches 0. So beyond this one we should stop. So I greater than or equal to 0. So when it becomes less than 0, it should stop. Then every time I should be decrementing, okay, comma, then j should be incrementing, j plus plus. Then while scanning through this array from back side and this from front side, we have to copy the elements into B at a location j from A from location I. This part is reverse copying the elements. Then after doing this, we have to copy the elements from B to A directly. So for this, we can start from here I, that same I can be used here also. 0, 0, then 1, 1, then 2, 2. So 0 is copied in 0, 1 is copied in 1 and so on. So again one more for loop for I assign 0, I is less than length. We have to go up to the last element, then I plus plus. In this for loop, we can copy the elements from B to A. So elements are copied in A from B. This portion is reverse copying, then copying the elements from B to A. Now from the code, if I see, then this statement is executing for n times, for n elements, and this we know well that the condition part, this one, will be 1 extra, so this will n plus 1. We are not concerned about this one. We are concerned about the actual work done. Then this statement is also n. See, these loops are not inside one another. They are after one another. So its time is separate, its time is separate. So it is 2n. So the time is order of n. Time is order of n. So this is one method of reversing. Now second method I will show you. In second method, we can scan from two ends of an array and interchange the elements, swap the elements. Like first element is swapped with the last element. We will swap these two elements, interchange them. Then these two elements are swapped, 3 with 12 and 9 with 2, then 15 with 7, then 6 with 10. We need two indices, I from here and j from here, then interchange the elements. So copy 4 here and copy 8 here. Then decrement I and decrement j. Then interchange the elements. So 12 here and 3 here. So in this way, if we continue, rest of the elements will also be interchanged. Like similarly, if we continue, we can interchange rest of the elements. So when we should stop? When I and j has came on the same place, or I became greater than j, we should stop. So in this way, we can reverse the entire array. So how much time it is taking? We have to scan through all the elements. How many times? Just one time. So time is how much? Order of n. We are swapping total n elements. We are accessing total n elements. Now for the same thing, I will write down the code and show you for reversing. We want I starting from 0 and j starting from length minus 1. Then this can be done using for loop. And how long we should continue? As long as I is less than j. When I becomes greater than j, stop. Elements are over. Then I plus plus j minus minus. What we have to do each time? Interchange the element, swap the element. So for swapping, we take some temporary variable and in that store a of I, then in a of I store a of j, and in a of j store temp. That's all. This is the code for reversing array. So we don't need an auxiliary array for this one. So the time is order of n. Now next let us look at left shift and then left rotation. Let us look at left shift operation. I have taken a small size array of size 5 and I have 5 elements in that one. Now what does it mean by left shift? We want to shift all the elements on the left hand side. Let us see. So from which element we should start? From this element, first element. If I shift this 6, there is no space here. 6 will go out. Okay, let it go out, no problem. Then 3 will come here and 8 will come here. Then 5 comes here and 9 comes here. Then this place is free, so we can put 0 there. So this is left shifting of elements. We will lose one element in this one. Yes. So it means if I have to shift right, then I should start from here. We will lose the last element and all the elements will move one step forward and we get free space here and it is 0. So just the direction is different, left and right shift. So just the direction is different in left shift and right shift. This is shift operation. Then what is rotation? The deleted element, the first element that you got, you copy it in the last location. It means that 6 has not removed, but it came here. So it is rotation. That's all. So shifting means just moving them. How many spaces you want, you can move. Usually we move by one place. Then rotation means the deleted element is copied at the last. This is called as rotation. How much time it has taken? We have moved an element, so the time is order of n. Shifting takes order of n time. And if you have to rotate, you can keep hold of the first element and you can copy at the last. So this is called as left shift and left rotation. Now what is the use actually? So for explaining the use, I'll show you. Now usually on display boards, LED display boards, we find that the advertisements are scrolled on the display board, that is LED board. For example, this word welcome is there displayed on LED board. So this can be constantly displayed like this. Assume it is LED board only, but actually it's an array. Now we want to show it as moving, scrolling. So what we have to do, this should move this side. So remove W, move E here, move L here, and C, O, M, E, and blank space here, that blank space here, that blank space here. At the end, add a blank. So W is gone. Now if I repeat again, this all letters will move shift on this side and E will be gone, then L will be gone. So it looks like as if this word welcome is going away. So it's scrolling. Now followed by that, you can start adding some other letters then. So the advertisements will be flowing from left to right. The advertisements will be flowing from right to left on the display board. So the advertisements will be moving right to left on the display board. So with the left shifting, we can show them as scrolling advertisements. If you want this to work just like this welcome word is going around and again coming back, it's like rotation. It's like rotation. Then for that, this deleted letter, you can show it here. So now this E will be deleted and added there. So that welcome will be coming again here and it is fading away from this side. Then again it will start from there. So this is the logic used for LED display boards. So this logic is common in electronics. So in computer science also this technique is taught as left rotate or right rotate, left shift or right shift. So that's all about the basic operations we have seen upon an array. So that's all about these operations. In this video, we'll look at operations upon array, that is First, I will write on a function for reversing contents of an array. Reverse, it should take an array and it should take by address, so its pointer ARR. Then for reversing, I have discussed two methods. So first method I will follow, I'll take one auxiliary array. So for that I will take a pointer B. Then I need other variables like I and j, I will declare them also. The first thing is the array B should be of size equal to array A. So I should take the size of an array A and create array B from heap. So I will create array B from heap by calling malloc function. So malloc, this should be same as length of an array. We don't need size, we need length. Length is number of elements that we are having. Then the next is size of its integer type, so it is integer. Now I have an array ready. Now let us copy all the elements from array A from right hand side to array B. So for that I will take a for loop, like I starts at array's length -1 and j starts at 0. Then we'll continue as long as I is greater than or equal to 0. Then I minus minus and j plus plus. Every time in B of j, copy an element from A of I. This will reverse copy all the elements of array A into array B. Then again I have to run a for loop starting from 0 and I is less than length I plus plus. I should copy all the elements from array B to array A. So A of I should be assigned with B of I. Yes, this will reverse an array. Let us call reverse function here and then we will display an array. Reverse address of array. And next statement is display. So this function is called and this function will reverse all the contents of an array by using auxiliary array B. Let us run the program. We should get this array reverse. That is, instead of 2, 3, 4, 5, 6, we should have 6, 5, 4, 3, 2. Yes, the elements are reverse 6, 5, 4, 3, 2. So this function is working. So once again, see, I have created a auxiliary array in heap. Then I have copied all the elements from array A to array B. In array A, we started from right hand side and array B, we started from left hand side. Then copying all the elements from B array back to A array. This is one method. And one more method I have shown you. So let us write a function that is reverse to second version. Reverse to, it should take an array by address. Now in this method also I need two variables I and j. So let us take those variables. And as I said, using a for loop we can exchange the elements. So for I assign 0 and j assign array's length -1, that is from the last index, and we should continue as long as I is less than j, and I should increment and j should decrement. Then every time we swap the elements, so already we have written a function for swap. In the previous videos I have shown you the swap function will exchange the values. So this swap function will call from here swap A of I with A of j, and I should pass their addresses, so I should write ampersand here for addresses. So that's all. This will reverse an array. So let us call version 2 from main function. So here inside main function, let us call version 2, that is reverse 2. Run the program. Yes, it is also reversing, that is 65432. It's working. So this was about reversing an array. So that's all in this video. We have two more functions remaining, that is left shift and right left rotation. Similarly, we have right shift and right rotation. So you can try those functions by yourself. That is a student exercise. Let us look at few more operations on an array, like inserting in a sorted array. We want to insert a new value in an array which is already sorted. So we should add a new value at a sorted position. The next one is checking if an array is already sorted. Then one more, arranging all negative elements on the left side and positive elements on the right hand side. So let us check these. So these are few simple operations, but that are important operations. So let us check how to perform them. Now the first operation, I want to insert a new element 18 in this array, and this array, if you observe, it is already sorted. So in a sorted array, I want to insert a new element such that it is inserted in its sorted position. So where this 18 should come? So if you check here, it is greater than 4, greater than 8, greater than 13, greater than 16, but less than 20. 18 is less than 20. So 18 should come here. This is the place for 18. So I have to insert 18 there, but already some number is present there. So I have to shift the element and make free space for 18, then only I can insert it. So for shifting, I should start from last element. I should shift 33, then 28, and 25, then 20, then I'll get a free space, then I can insert this one. Now let us look at the exact procedure. For inserting a new element 18 in this list, I don't have to find out its position by checking these numbers. I can simply start checking this number by the last. I can simply start checking this number from the last number onwards. If those numbers are greater than this one, I can shift them. If suppose this is not 18, this is 38, so this is greater than 33, so I can simply store 38 here. But this number is smaller, so I can start shifting them. So 33 has to be shifted, and 28 has to be shifted, and 25 has to be shifted, 20 is also shifted. Then this number is 16, so 16 is smaller than 18, so the next place is 18 only. So I can insert 18 here. That's all. This is the procedure. The important thing that we have to observe here is that you no need to find the position of this element by comparing these elements, because after comparison also you have to shift them. So directly start shifting them. Now let us see the procedure how I can shift the elements and I can insert this new element. Let us call this element as x. So let us say it is 18, for example. Then I should start shifting from last. So from here I should start. So let us call that I as length minus 1. That is, length is the number of elements in the list, that is 8. So 8 minus 1, that is 7. So I starts from 7. Now repeatedly what I have to do, I have to go on shifting the elements. So I have to go on shifting the elements, so that is while loop I will do. How to shift an element is this a of I should be copied at a of I plus 1. So a of I plus 1 should contain a of I. So I have to shift. This shifting has to be done repeatedly. How long? As long as this x is smaller than that element. If this becomes greater, then I should stop. If this becomes greater or equal, I should stop. So as long as a of I is greater than x. And after shifting an element, I should also decrement I. That is, decrement I. So I minus minus. So using while loop, I have written the code. Even I can use a for loop also. But for loop is useful when you know how many times you are going to repeat, and while loop, we don't know how many times we are going to repeat this one. We have to repeat based on the condition that this element is smaller than the element, then shift it. So I have used while loop. Now once this has finished, So if this loop is executed, then it will move 33, then also 28, then 25, then 20. Then when it comes here, it will stop. I will stop here because this element, that is a of I, is not greater than 18. So this is not greater than 18, so it is false, so it will stop. So where I should insert this new element, I plus 1 place. So at a of I plus 1, I should insert element x. That's it. This is the pseudocode for inserting an element in a sorted list, and it is one of the important procedures. Now let us move to the next one, checking whether the list is already sorted or not. Let us see how to check whether a list is already sorted or not. Here as an example, already I have a sorted list with me. So the procedure for checking whether it is sorted or not is start from this one. This is smaller than this, and this is smaller than the next number. This is smaller than the next number. So every present number is smaller than the next number. Then it means the list is sorted. If suppose here I have 26, then 4 is smaller than 8, 8 is smaller than 13, 13 is smaller than 26. Yes, up to here is correct. 26 is smaller than 20. No, wrong. So it means the list is not sorted. So the procedure is check the current number with the next number. If it is smaller, go on continuing. And if you have reached the end of a list, so finally in the procedure, we will check the current number is smaller than the next number. If not, then it is not sorted. If we have reached at the end of a list by comparing this, means it is sorted. I will write like an algorithm. Let us see. Algorithm is sorted. I am calling the algorithm as is sorted, and it takes an array and the number of elements. Now we have to start checking from first element, next, then next, so on. So until where we should continue, we should stop here, because we cannot compare 33 with any other number, right? So let us say there are 8 elements. N is 8. This is 8. So we should stop here. No, we have to stop before this one. So we should stop at -2 place. So using for loop, we can do this one. So for I takes values 0, I is less than number of elements. No, usually we reach till here when we say n, but we have to stop before that. So n minus 1, I plus plus. Then in this, what we have to check for? Is there any pair of elements where the first one is greater than the second one? It means the list is not sorted. So we'll check for false condition. If a of I is greater than a of I plus 1, any number is greater than the next number, then return false. Means list is not sorted. We got this condition satisfied, then we return false, means list is not sorted. And that's all, end of loop. If we have completed the whole array, complete array, and we never came across such a pair of elements, we have finished the array, means list is sorted. So from here we can say return true. That means list is sorted. So if at all anytime this condition is true, it will stop and say false. Otherwise it has reached the end, then it will return true. So in this case, it will check I with I plus 1. This is not greater, continue. This is not greater than this one, I or I plus 1. This is not greater than that one, continue. This is not greater than next one, okay, continue. This is greater than this one. Yes, this is greater than this one. So return false. If suppose this is not 26, this is 16 only, now it is completely sorted. So it will check this one with this one, right? So this is not greater, then this is not greater than this one. This is not greater than this one. This is not greater than this one. This is not greater than, not greater than. So till here it will check not greater. So here it will stop, come out of the loop and say true. So your list is already sorted. So this is also useful, like before sorting the elements, to confirm if they are sorted or not, we run this procedure. So how much time this procedure is taking? It is iterating through all the list of elements, then it is taking order of n time. If the list is sorted, it will take n. If it is not sorted, then it may stop at any place. That is minimum one comparison it performs. So minimum time is constant, maximum time is order of n. Now next we will see negative numbers on one side, positive on other side. Now the next problem, we have an array or a list which is having positive as well as negative numbers. This is an example list. It is having mixed positive as well as negative number. What we want to do is, we want to bring all negative numbers on left hand side, then followed by that we should have positive numbers. So in the beginning of an array we should have all negatives, then when negatives have finished, then positive should start. So but they are mixed, so how to bring them at one place? Let us see how we can do it. So for this we can take two pointers, that is index pointers. One is I from the beginning of a list and one is j from the end of a list. So I from here and j from here. Then using I, we look for positive numbers. If there are any positive numbers this side, let us send them there. And with j, we will find out if there are any negative numbers on this side. So let us send them here. So I will try to find positive number and j will try to find negative number. If found, they will exchange. So I will also simultaneously write down the code. I is starting from 0 and j is starting from length of a list minus 1. That is from there. Then what we have to do? Check, is it positive? If it is a positive, then we have to send it there. No, this is negative. So move next. Is it positive? Yes, we got the number. So it means I should continue incrementing until it reaches a positive number. So if it is negative, it should just move ahead. So I can write while a of I is less than 0, continue I plus plus. So when the number is negative, let I move ahead. If it is positive, it stop. So yes, we got positive. Then same way, j should be decremented until it gets a negative number. Is it negative number? No. Is it negative number? Yes, stop. So means j should decrement if the number is positive. It should stop if the number is negative. So while a of j is greater than or equal to 0, j minus minus. So if it is less than 0, it should stop. So yes, we got the numbers. Then what we should do? Interchange them. These numbers should be interchanged. So thus minus 4 is brought here and 3 is sent there. So we should swap them. So I will write on swap a of I with a of j. Now I should do the same thing. I plus plus. Is it a positive number? No. I plus plus. Is it a positive number? Yes. So this loop has finished. Then decrement j. J minus minus. Is it a negative number? No. J minus minus. Is it a negative number? Yes. So j is decremented until we got the negative number. Then interchange them. Interchange. So minus 9 comes here and 10 goes there. Now continue. I plus plus. Is it a positive number? Yes. The number is not negative, so I stops there. Then j minus minus. Is it a negative number? Yes. So when the number is negative, it stops. So then again swap them. So minus 7 comes here and 5 goes there. Then continue. I plus plus. Is it a positive number? Yes, it's a positive number. Stop. J minus minus. Is it a negative number? Yes, negative number. Stop. But now we will not interchange them because I has become greater than j means we have checked the entire list. So this swapping we will not do and we will stop the procedure. So this swapping is done if I is less than j. So this is conditional. So moving I and moving j, moving I, moving j and interchanging the element was repeating procedure. How long we have done this? As long as I is less than j, while I is less than j will continue. So this is the procedure for swapping the elements. So this is the procedure for arranging all negatives on one side and positive on other side. Now analysis, how much time it has taken. The time was spent on comparing the elements. So total how many elements were compared? N plus 2 elements were compared. We started from this with I, and from there also we started with the J, and I has increased and check one more number, J has also decreased and check one more number. So total N plus 2 comparisons were there. Then swappings, it depends. If already all negatives on this side and positive that side, no swapping will be done. But the main time is spent on comparing the elements. So we can say the time is order of n. This is scanning the whole list just once. An exact number of comparisons are n plus 2 comparisons. Now analysis. What is the work done here? Comparing the element and interchanging them. Interchanging is happening if there is a conflict in the condition. Interchanging is happening only if positive is on this side or negative on that side. Otherwise, comparison is always done. So at most, how many elements are compared? All n elements are compared. So the time taken by this procedure is order of n only. Order of n. So that's all. These were few important operations that are performed on a list. So we have seen them on an array. In this video, we'll have the demonstration for inserting an element in a sorted array and checking whether an array is already sorted or not, and arranging all positives and negatives on either side of an array. Already we have discussed this topic on whiteboard. Now I will write down functions for them and I will show you. So I am using the same program which we have already used in the previous topics. So all those functions are present in the same project now, same program file. And here I have an array which is initialized with some number, and these numbers are already sorted. Now let us write a function for inserting an element in a sorted position. I will call the function name as insert sort, and it should take a array as a parameter, and it should be by reference, and next is the value that we want to insert. So for inserting an element x in a sorted position, I should start shifting the larger elements from the right hand side of an array and make a free space for x and insert it. So I will write on the code what we have already seen on whiteboard. So before insertion, first of all, I should check whether there is any free space in an array or not. So if array's length is equal to array's size, then there is no free space. So I should stop the function. So I will simply say return. Means if length is equal to size, then there is no free space. Otherwise, I can insert. So for insertion, I have to shift the element. So for that, I need a variable I, and that should be initialized with arrays length -1. Then as we have already seen that I have to go on shifting the element, so I should do it as long as while a of I is greater than x. If so, then I should shift an element at a of I plus 1. I should write down the value from a of I. And I should decrement I. And one more thing I should take care that I should not cross 0th index. So one more condition, I should be greater than or equal to 0, as well as this condition should be satisfied. If I am inserting a smallest element, then it should come at index 0. Beyond that, and below index 0, there is no valid index. So I should stop when it has reached 0, right? So if it is becoming -1, it should stop. Then after coming out of the loop at a of I plus 1, I should store the element. As we have inserted one more element, so the length of array should also be incremented. So length plus plus. So that's all. The function is ready, which can insert an element in a sorted position. So let us try it in main function. In main function already I have an array. The largest element is 15. Now let us insert an element by calling this function insert sort, and it takes address of array object, and the value that I want to insert is 20. So let us first insert 20. 20 should be inserted at the end of this array, that is after 15, because this will be a greatest number. So display should display all the values along with 20. So this display function will display all the elements. Yes. Now it is displaying 6 elements including 20. Let us change the value. I will try to insert something between 10 and 15. So I'll give the element as 12. So it should be inserted after 10. Let us see whether it works. Yes. 2, 3, 5, 10, 12 and 15. It is inserted in a sorted position. If I give the value as 4, so it should be inserted in between 3 and 5. Yes, 2, 3, 4, 5, 10, 15. If I give a value as 1, then it should be inserted before 2 because it's the smallest element. Yes, 1, 2, 3, 5, 10 and 15. It is inserted. So that's all with the insert function, inserting in a sorted array. Next, I will write a function to check if an array is sorted or not, that is sorted. So return type is integer. It will return whether array is sorted or not. So it will return true or false. So true means it will return 1, otherwise it will return 0. Is sorted. So it should take an array. So struct array arr. It should take the value by value. We don't need by address because just it has to check. It doesn't have to modify an array. Then to avoid an error here, I will write return 0. Otherwise the compiler will show error here. As we have already seen the procedure on whiteboard, so we need to use for loop for scanning through this array. So for that I will take I, then for loop I starts from 0. I should be less than array's length minus 1 because we should stop one element before as we are comparing two elements. So every time check what if a of I is greater than a of I plus 1, then it means they are not sorted. Any two elements are such that first one is greater than the second one, then they are not sorted. So we will return false. False means 0. Otherwise, when we come out of this for loop, we will return 1. Means if return 0 was not done, we have checked the complete array and there was no such condition, that is the first element was greater than the second element. So array is already sorted. So this discussion already we have done. Now I will use that function. I will call that function here. So I will directly print the value. Printf %d/n is sorted. I will pass an array. So I'm passing this array to this function to check whether it is sorted or not. We can see that this array is already sorted, so it should return 1. So printf should print the value 1. Yes, it is printing 1. I will modify this array and make it unsorted. So I will write 25 here. So 2, 3, 25, then 10. So it is not sorted. See one of the element that is greater than the next element. Let us run and see what's the output. See, output is 0. Means it says that array is not sorted. Yes, correct. So it is returning true or false. So wherever you need it, you can use it to check whether it is sorted or not sorted. Call this function. It will help you in taking decision by sending true or false, that is 0 or 1. Now the next function remaining is rearranging positive and negatives. So for that I will write a function rearrange, and it should take a struct type array and it's going to modify an array, so it should be called by address. I'm calling the function name as rearrange. As we have already seen the procedure, so I will declare the variables I and j that we need. I should start from index 0 and j should start from index arrays length minus 1. That is the index of last element. Then using while loop we have to iterate as long as I is less than j. Then each time increment I, so I will use do while loop here. each time increment I as well as a decrement j. So I will use while a of I is less than 0, means if it is negative, then increment I. And same way, I should decrement j if a of I is greater than equal to 0, j minus minus. So this procedure already I have shown you, so I am not explaining it here. If I is less than j, then swap. So already we have a function for swap. So I will call that function swap by sending addresses of AR of a of I and array of a of j. These two elements we will interchange. So that's all. So if I have some positive and negative elements scattered in an array, then it will arrange all negatives on the left hand side and positive on the right hand side. So I will try to write some negative numbers also. Here is minus 15 and this is minus 3. So then I will add one more number here, minus 7. So this minus 3, minus 15 and minus 7 should be on the left hand side. So let us call this function. I will remove this. Rearrange, send the address of array. Now total elements are 6, so I should modify this length also to 6. Now let us run the program and see what happens. Yes, all negatives are on one side and positive are on the right hand side. So you can see that 2 is swapped with minus 7. Then 25 is swapped with minus 15. So 25 went in a place of 15. So that's it. This is working. We have seen 3 different functions, that is inserting an element in a sorted position and checking whether an array is sorted or not, or rearranging the elements. Yeah, in this video we'll talk about merging, that is combining two sorted lists into a single sorted list. Merging is a binary operation. It needs more than one array so that it can combine them into a single array. Likewise, merging, there are more binary operations on an array. Quickly I will tell about them. One is append, concat, compare, copy. These are some of the binary operations on an array. Here you need more than one array. Like appending an array. Already we have an array and there is suppose free space. We want to add these elements followed by this one. That is append. Concat, that same thing, combining these two arrays is concatenation. So it may be done in third array, like all the elements of array A, then all the elements of array B followed by that. Appending means that array is updated. Concat means that may be in some other array. It's the same thing. Concat and append are same. Comparing two arrays, comparing whether they have same set of elements or not. So one by one we have to compare the elements from two arrays. Then copying. So if you have an array of elements and there is a free array, empty array, we want to copy all these elements in this one. So this is copying. Now likewise we have merge. Now let us see what is merging. Merging can be done only on sorted list. So first array is sorted and the second array is also sorted. And we have to combine these two arrays and get a single sorted array. And for merging, we need definitely third array. We cannot combine and store only in A or only in B. We need one more array, let us say C. Now how to combine them? Before looking at the procedure, let us say the number of elements in this array are m elements and this array are n elements. So that is having m elements and this is having n elements. Now we will combine these two and store them here such that they are sorted. So for that we will take index pointers I, j and k. I start from first index of A and j starts from first index of B and k starts from here. Now what the procedure we perform is a repeating procedure. So what we have to do? compare A of I with B of J. Whichever is smaller, copy that one here. So if A of I is smaller, copy it. If B of J is smaller, copy that one. So right now A of I is smaller, so copy this the one. Then move I to the next element and move K to the next element. Then compare A of I with B of J. Now B of J is smaller, so copy this element 4 and increment J and increment K. So what we are doing here, I will write down a pseudocode for that one. Initially I is equals to 0 and J is also 0 and K is also 0. That was initial one. Then we are comparing if A of I is smaller than B of J. If so, then in C of K we will copy A of I and we increment K as well as I. Otherwise, in C of K++, we will copy B of J++. This is what we are doing. So let us continue. A of I is 8, B of J is 10, so 8 is copied here, I is moved further and K is moved further. A of I is 16, B of J 10, so 10 is copied, then J is moved further. A of I is 16, B of J is 12, so 12 is copied and J is moved further and K also moved further. A of I is 16, B of J is 22, this is 16, this is 22, so copy 16, move next, move next. A of I 20 and this is 22, so 20 is copied here. I is moved, K is moved. Now this is 25, this is 22, 22 is copied. This is 25 and this is 23, so 23 is copied. Then J++, K is here. So J became 5 now, means it has gone outside the size of an array. There are total 5 elements. So J became 5 now, it means the second list B has finished. We should stop. We cannot compare now A of I with B of J. Then what to do? Definitely there are some elements left over in A. Copy them. From wherever I is, from that same place, start copying the remaining elements. Suppose I have more elements, copy all of them. And definitely at least one element will be left over. So in our example, here we got one element left. If suppose this is not 23, this is 28, then this will left over, that 25 will be copied. So in any one of the list, at least one element will be left over, so we have to copy that element. So copy that 25 here. That's all. This is the merging process. Now let me complete the code. See, I was comparing and copying every time. Repeatedly I was doing. So this was happening while I is less than M and J is less than N. Compare and copy. But we have stopped when J became equal to N. So when it is less than N, we were continuing. When it is equal to N, we stop. We have to stop either if the first list ends or second list ends. Means I becomes equal to M or J becomes equal to N, we have to stop. Okay, we have stopped. Then what we have to do, copy the remaining elements. If in the first list, copy the remaining. If in second list, then also copy the elements. So for that, I will write on the code here. For wherever I is, let it be there only. I less than M, I plus plus, C of K plus plus assign A of I. This will copy the remaining elements from first list. If suppose there are some remaining elements in the second list, then copy J less than N, J plus plus and C of K plus plus, copy B of J. So this is the code for merging. So at last I will copy that 25 also here and move I and K also and stop. We have combined two sorted lists into a single sorted list. And this single sorted list is having total M plus N elements. Now analysis. What is the work done? Comparing the elements and copying the elements. Here we prefer copying of elements. So how many elements are copied? M elements from here, N elements from here are copied. So total time taken is M plus N. So it is written as theta of M plus N. See, so far I was writing order of, but this is a known one. We use a theta. We can use big O or omega or anything also, but usually theta is used. So I will explain you what is theta afterwards. So the time taken here is theta of M plus N. Total M plus N elements are copied, and this is the first time we are giving the time complexity in two variables, M and N variables. So this is a notation for merging. Wherever you see M plus N, then definitely there is merging used there. So M plus N is for merging. So that's all about merge process. In this video, we will look at a demonstration for merging two arrays. So first of all, I will create two arrays. I will directly initialize them. Struct array, I will call first one as ARR1 and I will initialize it. The list of elements are 2, 6, 10, 15 and 25. This is the first list, so there are total 5 elements. And the size of the array, I can give any size, so I will give a larger size, and the number of elements, that is length, is 5. This is the first array. Then second array, struct array ARR2. I will initialize the array first, so the elements are 3 and 4, 7, 18 and 20. Now the size I have to give size, it can be greater than or equal to 5 because I have only 5 elements. So let us give the size as 10, and then number of elements are 5. So I am taking same number of elements in both the arrays. Then the third array I want, so for that I want a function merge to create third array. So for that I will take a pointer ARR3. I will not create an array. Now these three variables, it is giving a warning that these three variables are not in use. Yes, we have not yet used them. This is the same program or the project that we have been using. So inside this I will write a function for merge. Merge should take two arrays. Merge should take two arrays. It should take by address. So first one is ARR1. I'll give the same name, struct array, and second one is ARR2. Then what are the things we require in this function? We need I and j that will help us tracing array 1 and array 2. Then I need third array for storing the merge result, and its array size should be 10. I will create an array from heap. So for that I will take a pointer star ARR3. Then here I will say struct array pointer malloc size of struct array. So this object will be created in heap so that I can return it and I can use it inside main function. The merge result, I should be able to use it in main function. So that's why I'm creating this on heap. Now I will write on the procedure that we have already discussed on whiteboard. While I is less than ARR1's length and j is less than ARR2's length, that second array's length. As long as I is less than first length and j is less than second length, we have to compare the elements. Now we have to compare and copy the elements. So I will initialize these variables. So I need k also. So let us initialize these three variables, I assign and j assign, k assign 0. All these three are initialized with 0. Now here I will compare and copy the elements. If array 1's element is less than array 2's element, then array 3's element should be set to array 1's element. And this I and k both should increment I as well as k. Else, in array 3, we should copy the elements of second array. K plus plus should be equal to assigned with ARR2's element. That's it. So this loop will copy all the elements by comparing them one by one, and it will stop when one of the array has finished. Now I have to copy the remaining elements from any one of the array. So I should start from wherever I is. So I is for first array length, then I plus plus, then in third array I should copy the elements from first array. And similarly, I will copy and paste this one. I will copy and paste this one, and this should be for j. Instead of typing again, I will make it for j. This j is less than array 2's length and j plus plus, and here j should be copied in k, and this should come from array 2. That's all. This will merge both the arrays and store the result in array 3. Now for array 3, I should set its length. Length should be array 1's length plus array 2's length. This I should set. And array 3's size is not set. I should set the size also to 10. That's all. Now as this array 3 is created in heap, I can return this to the main function. So I can say return array 3. And here the function should have the return type as struct array pointer. Yes, the function is little lengthy, but it is ready for merging. This is the function for merging. Now from inside main function, I will call merge by passing address of first array and address of second array, and the result I will take it in array 3. Then whatever the result I got, I will display that. So let us call the function display, and it takes call by value, so I should send star ARR3. That's all. Now these elements should be merged, and I should get all sorted elements in array 3. 2, 3, 4, 6, 7, 10, 15, 18, 20 and 25. Yes, perfect. It's working perfect. So merge function is merging all the elements. So this merge function we may be using at various places. So that's all we have seen merge function. That's all in this video. Now let us look at set operations. If the sets are stored in an array, then how we can perform those operations. So the operations are performing union of two sets, intersection and difference, set membership. So here I have example of two sets that are stored in arrays A and B. Some 5 elements I have taken. And I have taken one more example here. The difference is these elements are not sorted, but these are already sorted. So let us see how we can perform these operations if the elements are not sorted and if they are sorted. So let us look at union operation. Let us see how to perform union. So for that I will say this is having m elements and this is having n elements. Now what is the procedure? Copy all the elements of first array 3, 5, 10, 4, 6. So the first set is copied. How much time it has taken? M. Then I should copy second set. 12. Shall I copy it or not? See, I cannot blindly copy second set. If already it is present here, I should not copy it. 12. Search for it. Is it there? No, not there. Then copy it. 12. 4. Search for it. Is it there? Yeah, it's there. So don't copy it. Then 7. Search for it. Is it there? No, not there. So copy it. So every element I am searching here. Searching takes how much time? Depends on the number of elements present here. So already I have copied those elements here. So m elements are there. So it is taking order of m. So it is taking m time for searching. So let us continue. 2, is it there? Not there. So copy it. 5, it's there. So don't copy it. So 4 and 5 were already present here. So those are not copied. So every element we have to search. So how much time it is taking? M is the time taken for searching. No doubt the elements are increasing afterward, but let us say m is the time for searching. How many times we have done this one? For n times. So into n. So the total time is m is for copying first array elements. Then second one is copying second array elements, that is second set's element, but every element has to be compared. So this is m plus m into n. So this is the highest degree, m into n. So we will not use two variables, we will take single variable only. So let us call this as n plus n into n, that is n plus n square. So this is order of n square time. So for performing union, it has taken n square time. This is very slow. This is quadratic, time consuming. Now let us see, if we have sorted elements in the sets, then how we can perform union on those sets. Let us see. Let us say these are m elements and these are n elements and these are sorted. I have to combine them and store them in C without duplicates, that is union. So I can use merge procedure here. We have already learned what is merging. That same merging procedure we will perform. So what we will do is, let us say here is I and here is j and here is k. Compare A of I with B of j. B of j is small. Copy this 2. Then move j and move k. A of I with B of j. So A of A is small. So 3. Copy it. Then move this 1. A of I and B of j both are same. So copy that 4 and move I also and j also, and k is here. So if they are equal to this one. Now again A of I with B of j, both are equal. Copy it once, move I also and j also, and k is here. Compare A of I with B of j. 6 is small, so copy this one, move I. A of I with B of j. 7 is small, 7 is copied, move j. A of I with B of j, 10 is small, copy 10. Then leftover is 12, so copy that 12. So this was merging. Only a slight change is that if they are same, copy only once and move both I and j. So it is merge process, so it is m plus n. We can say this is theta of m plus n. If you want to represent this in a single variable, then you can say theta of n plus n. This is nothing but 2n. So 2 is coefficient. So leave it n. So this is order of n. So if the list are not sorted, it's n square. If they are sorted, then it's n. So that's all. This is about union. Now next is intersection and difference. So we don't have to learn much there. Now already we know how to perform union. They are similar with some changes in them. Now let us look at intersection. Intersection of two sets. We have to take common elements of A and B and store them in C. So the procedure is, start checking the elements of array A. Copy them in C. But before copying, check if this element is already present there. It's not there. So move to the next element. Is it present here? Yes, it is present. Copy that 5. So I am checking this element in this one. So I'm searching for that element here. How much time it takes to search for any element here? Like 5 I am searching. So it's take n time. Then search for 10 also. Search for 4 also. How much time it takes for all n m elements? So this is m into n or n into m. Then check next. 10, is it there? It's not there. Move to next. 4, is it there? Yes, it's there. Copy 4. Then move to next. 6, is it there? It's not there. Don't copy it. So while copying the elements from array A into C, check if they are also present in B or not. That's it. So every element I have to search here in n elements, and I have to search all m elements. So m into n. So if we write it in single variable, then it is n into n, and it is order of n square. So this is also time consuming. Now let us see how to perform intersection if they are already sorted. So here also we use the same procedure of merging. So for merging, let us start indices from 0 of each list, that is I, j, k. And in merging, we check which is smaller, A of I or B of j, which is smaller. This is smaller. Don't copy it. We don't want that element. Move next. Then compare A of I with B of j. That's smaller. Don't copy it. Move next. Now compare A of I with B of j. Both are equal. We want that element. So copy that element 4, move I as well as move j and move k. This is not merging but similar to merging. So we are using that procedure. Then compare A of I with B of j. They are same. So copy that 5, move I and move j and move k. Then compare A of I with B of j. 6 is smaller. Move next. Don't copy it. Then B of j is smaller. Move next. Then A of I is smaller. Move next. Finished. That's all. Stop. Don't have to copy anything. So the procedure is same as merge procedure, and the time is theta of m plus n. In a single variable, it is n. So in union, if you remember, we were copying all the elements and duplicates one time, but in intersection, we are copying only duplicates. Now the next operation is finding difference. Next operation is a set difference, that is difference operation. We have two sets, then we say A minus B, that is subtraction of two sets. A minus B means we want all those elements of A which are not there in B. So subtract the common elements between A and B and take only those elements which are only in A, not in B at all. So this is a difference operation. How to get those elements? So what are those elements? Let us see. See, 3 is not present in B, 3 is in the result, 5 is there, don't take it, 10 is not there, take it, 4 is there, don't take it, 6. So 3, 10 and 6, these are the three elements that comes after A minus B. So how to perform this operation? So we have to copy all the elements of A, but copying every element, check is it present here? 3 is not present, copy it. 5, it's present here, don't take it. 10, it's not there, take it. 4, it's there, don't take it. 6 is not there, take it. So every element of A is compared with all the elements of B, and if it is not there, then we are copying it. So we are searching here. So m elements are copied, and every time they are searched in n elements. So this is m into n. So in single variable, this is n into n, and this is n square. So the time is n square. Now how it has to be done in sorted sets, if the lists are sorted, then how to do that, let us see. We can again use the merge procedure. So we will take indices I, j and k. Now we will run the process similar to merging. Let us start. A of I, B of j, this is small. So we don't want the element from B at all. Move ahead. Compare A of I with B of j. 3 is small, copy it. Then move ahead. They are same, don't copy anything, just move ahead. They are same, don't copy anything, just move ahead. That's small, copy it. Move ahead. Then this is small, move ahead. Then that is small, copy it, move ahead. First list has finished. So stop. We are not copying from B, we are copying only from A. And we are running the same procedure just like merge. So the time is m plus n theta, and in single variable it is n. And there is one more last operation, set membership operation, that is to know whether an element belongs to a set or not. Like 10 belongs to set A or not. So search and find out, yes, it's there. So set membership is same as searching only. So that's all we have learned about set operations. Mostly they are binary operations. So that's all about operations on an array, that is ADT topic. So that's all. We have seen various operations on an array, that is on a single array, as well as binary operations, that is more than one array also we have seen. In this video I will show you union, intersection and difference operations upon set of elements. On whiteboard I have discussed two methods. One method for unsorted array and one method was for sorted array. And sorted array method was using merge. So I will show you a method using merge, that is for sorted array. So this is the program already we have written for merging, and it's a single project that I am using for all the functions or the operations on an array. This is the same project what I am using it for operations upon an array. So in the same project, I will use that merge function and I will convert into union, intersection and difference. So for that, first of all, let me take some set of elements. First set is having 2, 6, 10, 15 and 25. So in the second set, I will write down few common values, like 6 is common and 15 is common. When we perform union, we should not have duplicates. So for performing union, I can take the help of merge function. I will copy that same merge function and I will change it for union. So here I will copy that function and I will call it as union. So union for sorted array is same as merging. In merge process, this is a loop where it will compare the elements of array 1 and array 2 and copy the elements in third array in the sorted order. So the logic for performing union will also be same, only the difference is that if the elements are same, then we should take only one copy and increment in both the arrays. So I will modify this. See, this is if array 1 element is smaller than else. So I will modify this and here I will write on if array 2's element is smaller, that is a of j is smaller than array 1 of a of I, then copy this. Otherwise means if both are equal. If both are equal, then in array 3 of a of k plus plus, copy any one of the elements. So I will copy an element from array 1 and I plus plus, and followed by this I will also perform j plus plus, means I should increment both. So this should be inside the bracket because I have more than one statement inside else block. Yes. See, this is if array 1's element is smaller, and the second one is if array 2's element is smaller, then third one if both are equal, then copy any one element and increment both I and j. And one more thing I have to modify here is that length of third array will not be equal to sum of lengths of array 1 and array 2, but I can take it as k. Whatever the value of k is, that is going to be the length of third array. Then size is 10. So that's it. Let us try this. Instead of so that's it. This has become a function for union of sorted arrays if the arrays are sorted. I will change the function name. I will call it as union. Now let us run the program. I should get a union of these two arrays, so where there are no duplicates. So the elements that I expect are 2, 3, 6, 7, 10, 15, 20 and 25. So 6 and 15 are repeating. So they should be taken only one time. Let us run. Yes, 2, 3, 6, 7, 10, 15, 20 and 25. So there are no duplicates in this one. So this is working perfect. So this was for union. Then I will copy this function for union. I will make changes and I will make it as function for intersection. Here I will paste it. Then first of all, I will change the function name to intersection. Function name is intersection. So in your compiler, if you are unable to give long names, you can take short name. In intersection, we should copy an element only if they are equal. So I should not copy these elements. So instead of copying an element, I should simply say I++, just move to the next element, don't copy it. And in this case, if second element is smaller, then I should just increment j if the second array element is smaller. Then else means both are equal. See, this one, array 1 element is smaller, this one is for array 2 element is smaller. If both are equal, then copy any one of the element either from array 1 or array 2 and increment all I, j and k. And here we should not copy the remaining elements. We should take only the common elements. So remove the code for remaining elements. Two for loops were for copying the remaining elements either from array 1 or array 2. That's all. Copying only common elements. So this condition is, if I write the condition, then array 1's element a of I is equal to array 2's a of j. I have written the condition also. Otherwise, this just else is sufficient there. Now the code is readable. You can read everything condition here. That is, if this is smaller, increase I. If this is smaller, then increase j. If both are equal, then copy them. So if we come back to the main function, I have two arrays and the common elements are 6 and 15. So if I call a function that is intersection, then I should get the answer 6 and 15. I'm calling intersection function, then display third array. Let us run this. Yes, we got the result as 6 and 15, that is intersection of these two sets. As these two sets are sorted, so we are able to use the logic same as merge logic and we are able to find intersection. Now the third operation that I have to show you is difference, that is array 1 minus array 2 we will do. So I will copy the code of union. So I will paste it and I will modify that one for difference operation. This is for the union. So I will make it as difference function. Difference. Now in set difference, I should copy the element only from first array. So this part is okay, first array. And second array element I should not copy, simply I should increment j++. And when both the elements are equal, I should not copy the element at all. That's what the difference is. So here I should not copy any element, but I should increment I as well as j when they are equal. Both I should increment. And I should copy remaining elements only from array 1. I should not copy the remaining elements from array 2. Even if there are any remaining element in array 2, I should not copy them. That's it. So here only the elements of first array are copied. Second array elements are skipped. If both are equal, then skip both of them. So here inside the main function, if I take a difference a minus b, then 6 will not be there, 15 will not be there. I should get 2, 10 and 25. So let us call this function difference. Yes, 2, 10 and 25. This is the result I got. So that's it. These are the three functions we have seen. And there is one more function I have shown you, that is set membership operation, that is nothing but search. So either you can use linear search or binary search. Same function you can copy once again and you can change the name as a set membership function. So using merge algorithm, I have shown you three different operations like union, intersection and difference. And the first method for unsorted array, that is you have to implement those functions. So that's a student exercise.